Hello there. Welcome to another video from Aerology. So actually from this session to some few session after, I'm going to talk about distributed processing. And based on the comments I got from you, seems like you are more interested to write coding. Of course, some of you are interested in reviewing papers. I will have that part either, but in the few next session, I'm going to more writing code, especially for distributed system, playing with Ray and see what powerful it is. So for the reference, actually I'm reading a book, Scaling Python with Ray, and some of the sentences I'm saying here is from that book, and the example are in there. So we're going to like experiment with it. Sometimes we add some example to it, or like playing with those examples somehow that make a trouble for it. So actually, Ray is created by Berkeley in Rise Lab, and as I said, it is for distributed processing. But it is really cool that the Ray goal is uh, not only distributed processing, but it's like somehow managing distributed system, like managing servers automatically. And uh, like since introduction, AWS, Lambda, and stuff like that, so Ray got even popular, more popular. And Ray is using actor model. So if you're familiar with Akka or actor uh, model for writing program, let me share an example like actor model writing code. There are some like different papers here talking about this. As I said, Akka pattern. So you can like use Akka in Scala basically, or I'm not like expert in the Akka and actor model, but actually it is really cool because we have an actor, and maybe I can find some images. So you find the good images like this one. So we have an actor, and that actor is sending a message to another one. So these can be on one computer or distributed. And another actor is getting that message, sending another message to another one. So we can create any sort of distributed system that they have a complicated message passing uh, into it. So the good point it has, I mean Ray, it hides server. So Ray auto scale transparently and uh, manage server based on the application requirement. And also by supporting this actor model, Ray implement not only a stateless programming, but also a stateful one. Because typically for the majority of serverless implementation, we have the stateless programming, but like we can even create a end-to-end framework like microservices uh, based on this. And it allows you to specify resources, including hardware. Like for example, I can ask from this actor to another actor that you can only use like half of your resources for GPU for processing this message, and half of the other should be like for the next or for the uh, another task. So and also it support direct communication between your tasks. Uh, Means that it's not only for simple functions but also for complex distributed system. So this is really cool for Ray. As I said, Ray can also have the autoscaler and stuff like that. So let's search about that. Ray, I think should write Sterling, for example, to bring the documentation. So this is Ray. The latest version we are now working is 2.6. So, and we are going to have some example with it. So there are other framework or architecture that try to mimic some part of the Ray, but Ray is not only that. For example, the cluster orchestration like Kubernetes or Slurm, stuff like that, Ray can leverage this for allocating cluster nodes, or Celery for parallelization frameworks. Ray can also, the way that the distributed objects are distributed through the Ray framework, it can somehow support this. And like other framework like Spark for data processing, stuff like that, also Ray can handle it. And as I said about Akka, so Ray's actor framework, which is really cool. And it can also be used for streaming. So let's start with Ray. And what I'm doing here, I may start with a Jupyter notebook because that would be easier for me. And for that, we need to install some libraries. The first one that we need to install is the Jinja. And we also want to have some datautil. We want to have CloudPickle and packaging. These are some libraries that we will use it during using this tutorial. We need pigments, psutil, nbconvert, and finally the Ray itself. Okay, hope that sorry, nb, like that, nbconvert. Okay, we need to update my pip. Let me try that. Let's this again. Let's try this again. Could not find a version that satisfies. Let's nb convert. Oh, again, another issue. Okay, so collecting Ray, installing Ray. Cool. So Ray can also be installed for ARM. So if you are using a Linux machine or ARM somewhere else, you can still use Ray. So I will wait a few minutes while this is installing. Let me write the first example. So what I can do is, suppose what I'm writing here is on one machine, but I will try to do it like in different machine too. So I have a function, that function is called hi. I'm just following the tutorial of the book for now. And I'm importing OS, and I'm also importing socket. And what I can do is I can say, we are running a socket, so we can say running a socket on, we can have the socket get hostname, okay, and we also can get the PID in PID from OS. So get PID, which give us the PID of this one. Yeah. Because each of these can be like a process. Sorry, it should be get PID. Each of these function, I will show you that would be like, each call would be like a process on the system. So if I call this function and I say hi, it said running socket MRM, this is my host name on this PID. If I do that again, the OS get PID is always same, yeah. So Ray, what it's doing actually, it's we can have an annotation here, function annotation. We can say Ray removed, and by doing that, now we can access to this function from a remote machine, or it's like an actor model, as I said, that you can now send a message to this function. Very easy. But instead of calling this way, like hi, we need to have the name of the function like high in this case, and then we can say removed because we want to remove, and that will give us a future, like the asynchronous call of that. And then if we want to get the results, let me run this. So when I do this, array is not defined. Sorry, I should import array. So yeah, so if I do this, it's doing that and said it started a local array instance. So actually it is running an instance. So array is a binding on a C++ and Python. So it's running an instance there. It said IP widget. That is not important, but about this one, the worker is defined there. So the worker is there. If I want to get the result, I can get array get, and I get this feature. And now it's returning this to me. And if I do that again, so because there is only one worker, that should work like that. If I again call this and do this, I should get the same result, because the high is defined once and high remote is also defined once. If I do another one, future 2, when I get this one, what will happen? So you see the PID change, because every time, let me show you maybe this way. We have feature, so maybe feature 1 and feature 2. So I have 2 instances of this remote function. If I say, give me this is the PID of feature 1. Give me this is the PID of feature 2, sorry. So means that it is on the same host, but on the different process. So this is really cool that now we can call multi-process here. If I have like 100 of these, I can call them in a for loop, and that should be okay. Yeah. So it is not somehow like feasible now. Let's try it and see how it's working. So if I have something like timer here, if I import time and I say time.asleep for 1 second, okay, now I can get the feeling that how can work. So let me have another version of this high. I call this high remote, okay, and I have this high remote here, and I have another version of this, but this time not high remote, just high. Okay, just high. So I want to just compare the two different things here. So if I import time it, because I want to calculate how much time it will take to do it. So what I'm gonna do is I'm going to create a function here. Let's see what I can do to show the difference better. Yeah, maybe it's better to have like an input here like x. I don't work with x, but just as an input to like make a difference between these functions. And I create a list like number of x instances are in range n. We have something like this, and now I can say I want a for loop. I use map for this case. I want a for loop over high with these x instances. I have this one, and now by having this, I can call this as a result of the first call. So I can say high result. As an example, let me remove these two, not making any problem for us. And I have high remote, but high remote.remove because I want to call them differently. And actually, the thing is here, because this remote, I didn't explain this, but I have to. So every parameter we have here, it should be passed through this x. So I'm not able to do this because this is two function here. So I'm going to use lambda. So I'm going to do lambda x, and everything will go here, x instances. And let's make this instances, and we have x, and that should be high result remote. Now, with the help of timeit, I can remove this. I can say timeit what? These are now like a generator. We need a list over it. So I can say lambda again, and a list over the first one. The first one is easy because we don't need to do anything like we don't need to use get function there. And the number of time that we want to time it is just one. Just try it once. And same thing for the second one, but for second time, we just don't want to get this. We want to have array. You remember that array.get, and then we will have this. Yeah, and sorry, this should not be here. This should be array get, the list here. And for lambda, I don't have any parameters. That would be simple. So we have one parenthesis here. I should close this also. Number is also 1. And did I miss something? Array get. Oh yeah, so after getting these, I again need to list them. So, and this is this one, not iris. Okay. And now I can maybe put this on vanilla call and call this remove call. And here I can print vanilla call is taking how much time? And same thing for remove call. Yeah, let's try this. So if I try this, I have, first of all, 10 seconds here. So what happened here is I'm calling this high for all of these instances here. So 10 seconds there. And then for the second one, I'm again calling high remote, but this is not going to wait until this is done because they're just sending it. So that would be like asynchronous, and we are not waiting here. It will asleep. Each worker will asleep with a different PID. They are calling each other. Then when we are using this function get, we just get the result of it. So by this lambda, we say, give me the result of this higher res removed and give me the result back. So we actually asleep just for 1, and we had like a little time for like, this is for I think this printing, no, not having printing, like getting the PID or getting hostname maybe took time. It should be 1 in the ideal case, but this is interesting because we have 10. This is really 10 times calling it, and it's waiting 10 seconds totally. So this is actually a real multiprocessing now. Yeah, and one of the cool things that it can be used is not only for this kind of calling, it's for some of the problem that need to, for example, write a recursive algorithm. So if we have a recursive algorithm that is high remote need to call it itself, we don't need to wait until that call is done. We can get the result later. And that would be a lot of improvement in performance, especially in the Python, that we don't have that much parallel processing because of the GIL curse. And Of course, there are some talking about that they are removing GIL, but it's not working. I think so. So, what else we can do? So, maybe to not make a long video and make you tired, I can make this a smaller chunk, and every time I provide one example. And after all of them is done, I will share notebook with you. So, so far so good. I will continue on that. See you in the next session.